Okay. So now the recording has started, and this is where we were yesterday. Okay. Next thing we want to understand is where we was in terms of applying the labels. But before we apply the labels, let's clean up the output so it looks a little bit easier to read. And I'm going to make my screen a little bit smaller so I don't take up all the space, white space over here. That way you can see my PDF as well more easily. Okay. Now, the next thing we want to do is learn how to apply the labels. And yesterday I told you that there are 3 types of labels that you can have. One is a label for the data set itself. So currently, if we do describe, you see that there's no label for the data set. So I can add a label to this data set if I want. Here I'm adding this particular label, and the command for it is you first type the command label, then what is it to be applied on, which is the data, and then anything you want to type over here. So here I'm typing data on sample of wages, source Woolridge 3rd edition, meaning I took this data from this particular textbook. Okay. And now, after hitting enter, if I type describe, you'll see that this appears up here on the label of this data set. Previously, there was no such label appearing up here. Okay. So that's the type of label that we can have for the data set. The next is the label that we can issue to a variable. Now, all our variables are already labeled over here. So for instance, wage has a label called average hourly earnings. Tenure has a label called years with current employer, and so on. Supposing I wanted to change one of these labels, or if it didn't exist, add it. For both of them, the command is the same. So for instance, if I wanted to change the label on the variable called female, I would add the command label. Then what to apply it on would be on variable. And then I have to specify which variable am I to apply this label change on. So I have to specify a name of one of these variables. So here I'm choosing the one called female. And then within quotes, I'm saying, here's the new label. So currently, the current label is equal to 1 if female. I'm saying label it as something called gender, and parentheses, write 1 equal to female, and I can say 0 equal to male, for instance. So it's more explicit. Even if I hit enter, that will become the new label. And the way to test is you can again do describe, and you'll see here's the new label that's showing up. Compare it to the old label up here. Okay. And this we can do for change it again. So I'm going to do it for both of these variables. And if I do describe, both are now per this command that I had given. Okay. So that's the second type of variable that we can, or label that we can change. Next is the value label. Remember I said there are 3 types of labels. So the data label, the variable label, and then the label for the values itself. So by that, if we look at the data over here, and if I look at the column for instance, female, this one, you'll see that the values are 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 0, so on, which basically is telling you that the data type is numeric and it is coded as 1, 0. So here's a variable female, and up here it's telling you that it is a numeric type with double values. It should have been binary to make it shorter, but that's what it is. So it's keeping a precision, very high precision, even though it does not need to be, it just needs to be 1, 0 variable. So here's the variable, and it's listed. Now we can change it by defining first a value to it. So I'm going to first do a define. So For define, I'm going to say label, and then the word define, that's the keyword, and then a name I'm creating. I'm calling it gender, and saying that when gender is 0, it will be the word male. When it's 1, it will be the word male. So I've just created that label. Now, if I go and look at the data, it will still be the same. Look, nothing has changed over here. 1 zeros are still there. And the reason for that is that while I've defined it, I've actually done anything with it. It's not a new variable. It just exists as a label right now that has not been applied. So once I create this definition, the next thing I have to do is apply this to some variable. So here I'm going to say label values. So label the values of the variable called female. This was a variable female per this definition that I've just created up here called gender. Okay. So here I've applied it. Now if I go and look at it, look, the column for female is got the words female, female, male, 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 female, female, male, male. However, what is very important over here is that I have not actually changed the values. The underlying values in the data set are still stored as a numeric value, 1, 0. So I can still do my arithmetic on it. I can still find the average value of this or the mean value and so on. You can't do that to string variables. It's just that its appearance is with the word male and female. The other way to tell is that if you look at this variable, it still says it's a numeric variable. Okay? So I can still do some, for instance, female, and it still tells me that here's a variable on which you can compute the average value, standard deviation, minimum, maximum. It says the minimum value is 0, the maximum value is 1, the average value is 0.47. It's just that if I print it out or see it on the data set, it will show, for instance, the word male or female. So I could say list wage, female, race, or sorry, not race, non-white, and in 1 in 10 over here. And you'll see that it's showing the first 10 observations like this. Now, if I've done it for the gender, I can do the same thing for the race as well. So again, I'll first create a definition and then the value, done in exactly the same way as before. So our first is label define race. 0 is white, 1 is non-white. I define that. Sorry, the word L did not go through. Label. Yeah, it's defined, and then I apply it. And now, if I do this print command as I did before, instead of writing 0 or 1 over here, it will write their actual race. And in fact, if I look at the entire data set, the first 10 observations obviously only have white in there, but here was the 25th observation, 26th observation, so on. Okay. Any questions so far? I don't want to go too fast. I want to make sure that you're following through where I am on it. Any questions, anyone? No? Okay. Well, once we've done it this way, then you can see that what the advantage is. I'm redoing the tabulate command as before and saying by female, by gender and non-white, tell me the mean values of the wage. And now it's more clearly labeled which group we are looking at. Okay. Then we can also create new variables. So we have a bunch of variables over here listed here, but when we're working with these, sometimes we want to transform these variables or create new variables out of them, or add two variables to create a third variable. Any of those things could be going on. A simple example is, for instance, when you have the wage variable, page variable available, and you don't want to work with that, but you want to work with the transformation of it. Here we're going to use a simple transformation, which is that I'm going to create a log of it. Now, before I do that, let's look at the histogram of page. And if I do that, here's what the histogram of page looks like. It's fairly highly skewed, right? And often enough, we want to work with, when the data is that skewed, we want to take a transform that will reduce the skewness in it. So we could create a log transform of it. The command for creating a new variable in STATA, a simple command, is the word gen for generate. So gen will create a new variable, and the syntax is as follows. You issue the word gen, short for generate, the new name that you want to create, or the new variable that you want to create, so give it a name. So here I'm giving ln wage, and then I'm defining how it should be created. So in this case, I'm saying it's just the log of a wage. Okay. So I do that here, and suddenly you'll see that in the data set, I have an additional column. So here's my wage column, and here's a new column called ln wage. I can even do histogram of this just to see what it looks like. And you'll see that, it's not a whole lot improved, but this is what it looks like. Yeah. So this is what the log transform looks like of this data set. I'm going to get rid of this variable. To get rid of a variable, you can use the command drop and then do ln wage. And that variable is, again, you'll see, is gone from the data set. There is no ln wage as it was up here a few minutes ago. Okay. Why am I doing that? Because I'm going to recreate this variable in a slightly better way. This was a crude way of creating it. Sometimes you want to think of possibilities that there could be something going wrong with the data or account for that. And so the way you want to do it is account for any errors. Now, wage should never be a negative number, but it could be that if you had drawn this data from a large data set, there were some errors in it. And one way to get around those errors so the software doesn't cause any problems, although in this specific case it wouldn't, is to first create a variable called log wage, which is just blank. So dot means missing value. If you look at it over here, I've just created log wage as missing values. Let's keep an eye on that over here. I'm going to keep that here. Now, what I'm going to do is issue a command which says replace. This is a new command you're learning, where you replace the value of ln wage from dot to be ln wage equal to log wage if the following condition is true. So if wage is greater than 0. Why? Because log cannot be taken of negative numbers. So I'm saying replace this with this bit. If the wage itself is greater than 0. And you'll see that when I do that, all these values will change to the log of this first column, as long as the value in here itself is greater than 0. Okay. So let's hit enter. And now go back, and you see that all those missing values have been converted back into a proper value. Okay. Okay. This is the same. Here I'm creating some extra labels. Another example, I'm creating a variable called region equal to 4, and then I'm going to set its value equal to 1 or 2 or 3 so that everything is not 4 if either north sen is 1 or south is 1 or west is 1. What am I trying to do over here? If you look at this variable, these variables, you'll see that you have dummy variables for the region where the person lives in. They live in north central, south, or west, which are coded as 1. North central, south, or west part of the country, if they're living there, it gets coded as 1. And since they can only live in one place, any one of these will be 1, but not all of them. However, there are some places where people are coded as 0 for all 3 regions. What's the reason for that? Because US is divided into 4 regions. So if all these 3 are 0, then they're living in the 4th region, which in our case we're going to call north, central, south, west, and I believe the 4th one will be east. So we're going to create a new variable which will take 4 values. 1, if somebody is living, if north central is equal to 1. 2, if south is equal to 1. 3, if west equal to 1. Note, however, that I'm putting in double equal to signs over here. This is a way of, in the condition being that comes after the word if, a value has to take on a value equal to 3 or 5 or 1, you type it with double equal to. But not when you're generating its value. When you're generating, it can be on its own. So I'm going to issue these 4 commands. Well, let's first generate one of them. And if I just do this, you'll see that a new variable is created at the bottom. Here you can see ln region. And if I do summary statistics on it, its mean is 4, its standard deviation is 0, its minimum is 4, its maximum is 4. Why is that? Because all values are equal to 4. There, it's throughout 4 everywhere. So now, instead of letting it stay at 4, I'm going to issue these commands that if replace region equal to 1, if north central equal to 1. And if I go in here, you'll again see that it's now either 4 or in some places will have become 1. Here it's 1. Where does it become 1? Exactly when north central variable was taking a value of 1. Okay? In exactly these, it's jumped from 4 to 1. But we're not done. So we need to now issue these remaining 2. So it takes the appropriate values everywhere. And now you'll see that if I do tab region, it will say that there are 4 values that's taking 1, 2, 3, or 4. 1 for 132 areas, 187 for 2, 89 for this, 118. So just like we did these wages by gender and race, we could also do them, for instance, by region. So now I could do tab region, comma, sum wage. And now it tells me what the mean wage is in different parts of the country. So in region 1, region 2, region 3, region 4. We could also do it by region. And for instance, female. So now it says in each of these regions, what are the differences in male, female wages by region. I could change the order, for instance, over here. So it would be female first, region second, and then regions appear here, 4 columns, and gender appears here first. So the first is the mean wage, the second is the standard deviation, third is the number of observations. So everything that we were doing earlier in the 2x2 cases, we can now do it in the 4x2 case. So 4 regions, 2x4 cases. So 2 genders and 4 regions. Okay. So this way you can tell whether the disparity in the male-female wage is greater in certain regions than in others. So for instance, in region 1, the difference is slightly less over here, 4.4 versus 6.9, versus here it's 4.6 versus 7.8. Okay. So region 4 was south. So in south part of the country, the wage differential between male and female is even larger. That's what this data is telling you. Anyway, back to the commands. Just like I used equal to here, we could also use other logical operations, which I've listed over here, but you can look them up when you're doing it. All right, that's pretty much about it. I'm not going to do OLS regression because that's not part of this module. It's there in the STATA manual. If you wanted to do this, you could certainly do it. The commands are given over here. I'm going to instead now switch over to a new data set and work with the problem set that was given to you. Let me stop here. And if there's any questions, or take a pause and answer any questions if you want to ask any. Anyone with any questions? Nobody? Is everything perfectly clear? Should I go a little bit faster? Should I go a bit slower? Any suggestions? No. Bit slower, but good for me. It's clear, all clear so far. Okay. All right, I'll try and go a little bit slower. All right, so 2 people are saying. Please do prompt me along the way to slow down, or ask me to hold on, or just ask a question so I do slow down, because when I don't hear responses coming in a classroom, physically classroom, you can see whether people are following you or not. But for me, I'm teaching literally to a blind audience, or to an audience that I can't see. So all I can see is my own computer screen, so I can't tell if somebody is falling behind. So please do ask me to slow down or ask questions along the way. Okay. Let's open a exercise over here. Okay. So you were given this particular data set. Now you won't be able to answer each and every question out of this right now necessarily, because some bits about hypothesis testing, etc., if they are towards the end of it, you won't be able to do those. But the earlier questions on inspecting the data and checking other things, you can already do them. So let's look at this exercise and see how to enter this into STATA. Okay. So for first part, I'm going to enter this data, and I'm showing you how to do it in STATA. Certainly you can enter this on a calculator as well. The easiest way to do it is by entering the data in Excel first, and then copying it from there. So the height is given as 66 and so on. Let's put that over here. Bring this over. So let's enter the 66, 68, 69, 70, 71, 72, 73, 74, and 76. Okay, so this is the data. I'm going to clear this data set, so everything is gone from the memory, because if you recall, I said you can't load a new data set until you get rid of the previous one. And now I'm going to select these, Control C, go in here, open data editor edit mode, Control V. It asks whether the names should be kept or not. Certainly I had a variable called height, so I'm going to keep that. So my data is in here. Okay. Now, so the data is in. That takes care of this first part. Okay. One second. All right, so it says find the mean, median, variance, and standard deviation of the sample. Now you can calculate this by hand, you can calculate this by a calculator, or if since this is a STATA session, I'm going to show you how to calculate this in STATA. So if you wanted to get the mean, median, variance of these data sets, what commands have you learned so far that could help you get, for instance, the mean value of the height? Any takers? Just write out what you think should be the command that you could issue in the chat. Any guesses? Any command that we've used so far? Yeah, sum, that's right. So go ahead, write sum, and then what do you need to write in front of it? The word height. Otherwise, if you don't do that, it will provide you the summation or summary statistics of all the variables in the data set. And all the variables in the data set add up to exactly one variable, so it will still be the same answer. So go ahead and type sum height. And there you go. So now we know the mean, which is 71. We know the standard deviation, which is 3.11249. What do you think is the variance? How do we compute that? Well, that's the square root of it. So I can do di as my calculator, take the number 3.122449, raise it to the power 2. That's the hat that I've drawn, or the carriage, and hit enter, and I get variance as 9.75. Okay. Now what's missing? What's missing is the median value. How do we get the median value? How do we get the median value? Anyone? Sum, maybe list. Sum, comma, details. That's right. Sum, height, comma, detail. And then you get the median value, which is 71. Okay. Okay, confirm your answer using STATA. We are informed by the government health department that the population mean height for adults is 70.5. How should we calculate the variance and standard deviation of sample when this information is available? When this information is available, you would what you would do is that the formula that you use in computing the variance, over there you typically put in X bar in that formula. You would, instead of using the X bar, you would use this value that's already given to you as the population mean, 70.5. That would be the only difference that you could use. So instead of mean being 71, you would use mean being 70.5 in there, and the rest of the calculation would be the same way. Okay, now I'm going to open a different file called wages. That's not the one that we were previously looking at, and generate the frequency distribution. Recall the raw means ungrouped. Use STATA to obtain the mean, median, and histogram. Do you obtain the same answers as question 1? If not, why? Question 1 is from the previous exercise that we're talking about. So here I'm going to get the data set from here as the probability 2, data instructions and data set. Here is the second data set, data 03, wages. So I'm going to right click on it, save link as, I'm going to download into the same location as yesterday. And while I'm here, I'm also going to download weight and fez, because I'm going to need those as well. save link as weight, and save link as Fez. Okay, so now that's done. We go back here, sorry, and clear the data. It says use the data set called wages. And now I do histogram, wages, or wage, sorry. And there's the histogram for the wage that gets drawn. And you were asked to draw this in exercise 1 as well. There was a very similar data set given. Note that the heights over here are almost the same, the widths, except for this last one. And if you look at the notes that I've distributed or solution that I've distributed for this problem when you were supposed to do it by hand, you'll find that for the last one, the bin is much longer, which is exactly what this computer is capturing. Yeah. Let's work with a more fun data set, which is the Fez one. So I'm going to get rid of this, clear, and then type use Fez. Okay. Now, let's go through this. The question introduces to some useful features of STATA. The file Fez contains information on a subsample of households from an old family expenditure survey. The variables are EXP, which is the total annual expenditures, adults, which is the total number of adults in the household, and kids, which is the number of children in the household. So here's the three variables that you can see, EXP, adults, and kids. If you want to look at them, here's what the data itself looks like. Okay? And if you scroll down, it shows that there are 700 observations. Okay. Now, retrieve the data and answer the following questions. How many households are in the sample? How should I get the answer to how many households are in the sample? So please type your answer here if you think what's the best way of finding out how many observations there are in the data set. If I type describe, it gives me information, meta information. So what's the first thing it's telling me? It's telling me the number of observations. So that tells me how many households are in the sample. It's 700 observations. Okay. Describe the 100th household. How do we do that? Any guesses? How do we describe the 100th household? I'll give you a hint. Something that Althea wrote in the chat a little while ago. Oh, sorry, there's another question. Where did you find the Fez data? Sorry, did you miss that? Fez data is here in the same location, data set number 5, FES. FES. Did you see it? You can download it from there. Okay. Good answer. You can use the list command, but the way you want to use the list command is you can say list in, let's say 99/100. This will print the observations on screen for the 99th and the 100th household, and then you can just read off the 100th one. So the 100th household has, the way to describe it would be, it's a household with 3 adults, 5 children, and with an annual expenditure of 10,302 pounds and 80 cents. That's all you would need to describe. What proportion of households are 1 adult households? How should we find the answer to that? what proportion of households are one adult household? What could we do? What commands that you have learned so far of the commands that I've shown you that you could use to answer this question? Take a guess. There's only a few commands I've taught you, so it's got to be one of those. Will describe do it? Probably not. That describes the whole data set. What else? Anyone? Anyone? Please write your best guess there. Tab, yes, excellent. Tab, adult, even better. Yes, go ahead, type tab adult. Adults rather, it's case sensitive. So tab adults. So list adult equal to 1. You'd have to do a lot of count, and there you would have to write list adult equal to 1. Not single 1, but equal to. Let's see what all three of them do, or both of these do. So tab adults. And with tab adults, you find that households with one adult have 135 is the number of observations, and they represent 19.29% of the sample, which answers this question. But it also lets you do it for 2 or 3 or 4 and so on. If, on the other hand, we did list, as was suggested, then we would need to do list adult equal to 1, but it should still give an error because we need to then put the condition that the word if. So here it should not recognize it, but if I put in the word if adult equal to 1, it's going to print all those households in which the number of adults is equal to 1. So how many observations will it print? We know from the previous answer, it will print 135 observations. So it will still not be fully useful because then we have to manually count how many observations it's printed, right? And it's not easy to count this way that how many observations have been printed. What it's saying is the 10th household, the 15th household, the 16th household, 24th, 37th, or so on, are the households with one adult. And it's printed everything about them, but it's difficult to sort it this way. What you could do, James, is that in this one, rather than list this entire table, you could say list adults if adults equal to 1, and then it will just print that single row of this table. But it will not be very useful because while it will tell you the frequency is 135, as a percentage, since it's conditioning it on those 135, it will say it's 135 divided by 135, so the percent will show will be 100%, which again doesn't make sense. So the best thing to do is the original thing that was suggested, which is just do tab and adults, and you get the answer. Okay. All right, how many adults have one adult and 3 children? Now what do we do? This time we don't care about the proportion. We care about the frequency. So we could do 2 things. One is, as you've just suggested, tab adults kids and look at the cross tabulations. The other is we could now do, for instance, a combination of tab and conditioning. So let's try both of them. But the right way to do it is the one that Zach has just suggested. Tab, kids, adults, and there you have it. So what's the answer? How many households have one adult and 3 children? Write your answer by looking at this output onto the chat channel. 1 adult and 3 children. 6, correct. 6, correct. Go on, everybody type in 6. Excellent. Okay, so here's the other way of doing it. So this gives us the full thing, full range. I could have conditioned it on one of these two. Since we're not interested in the percentages, I could have said tab kids if adults equal to 1. So then it would do just printing of this first column, which would also allow you to read off the answer. So again, the answer would be from here 6. Or you could restrict it so that it just prints this third row, which you would do tab kids, tab adults if kids equal to 3. And then if kids are equal to 3, the number of adults could be 1 or 2 or 3 or 5 in this data set. And when it's 1, it gives you 6. So 3 different ways of skinning the same cat. This is the most sensible way, unless the categories are too many. So the only times you want to start restricting it, use this method or this method, is if the number of rows or columns was so large for one of the categories that it becomes unwieldy to look at the screen. So then you say, okay, let's limit it in this way. What are the mean, median, mode, and number of children? Well, for that, we already know how to do that. So here's the histogram for, first we do sum for kids. That gives you the mean, as well as standard deviation and so on. Next, we could do sum kids detail, and that would give you the median. So the median number of kids in a household is 0. And finally, we want to do the mode. What is the definition of mode? Mode is what is the maximum value observed, or which has the highest frequency. So how would we do the mode? Any ideas? Any ideas on how we could find the modal value? How about hist kids? Can you now tell the answer? What's the modal value? Mode is the one with the highest frequency. 0, correct. You could have gotten it this way, or you could have gotten it with tab kids. Here again, you will see that 0 has the highest percentage, 52%. Okay? So either of those two would have worked. What is the highest number of children in a household? Well, highest number of children, you could just look at it from here. Max is 6, so that answer is there. Compare the mean and median expenditure. What does this comparison tell us about the distribution of household expenditure? Draw a diagram if you have to, if you want to. So compare the mean and median. So let's do hist exp detail. What's wrong? Oh, I'm typing the wrong word, sorry. Sum. Okay. So the mean is 3942. Median is 3902. Now that tells me that the mean value is slightly to the right of the median value. When the mean is to the right of the median value, what do we know? We know that the data has a bit of a rightish skew. How do we know that? Let's just see from the lectures. There was a point made in the lectures about it, I believe. When the mean and median are equal to each other, it's a symmetric distribution. When the mean is greater than the median, which is greater than the mode, it has a bit of a right skew. When it's the other way around, mean is less than median, it has a left skew. So Here we have the mean 3942 versus 3902 as the median. So you can see it should have a bit of a right skew, and we can check that more by doing hist exp to verify, and you can see that there's a right skew to this. There's these values going all the way out here. Okay. Draw a histogram of expenditure. Does the histogram confirm the conclusion in G? Yes, you saw the right skew. What are the features of the distribution are obvious from this histogram? You can tell what the modal value is. It's somewhere over here, which is, you can put a better plot of it and get that, or you can say, well, it's roughly around 2,500 or something like that. Find the mean expenditure of the households with 1 adult and 3 children. How should we do this? Find the mean expenditure for household with 1 adult and 3 children. Any ideas on how we can find this answer? Again, it's a combination of your tabs or your if conditions and summation. So take a guess or try it out on your computer. It's not too difficult. Tab, adults, kids, comma, sum, exp. And no frac, no std, and okay. So these are now providing the mean values for the variable expenditure for different combinations. So what is the right combination that we want? 1 adult and 3 children. What is the mean expenditure? Please write it out in the chat channel if you can see the value. 1 adult, 3 children. What is the mean expenditure? Very good. Yep, 5095.0833. Excellent. Okay. Now, challenge question. Use a slightly different 5095. Yes, correct. 0.083, correct. Use a different, what's an alternative command you could use which uses the if in it that will give you the same answer? Can you think of an alternative command that would give you the same answer but uses the if command? No takers? Zach, very, very, very close. You almost got it. Yes, you just need an ampersand sign between the kids and the adults. So when you're trying to create two sets of conditions, one way to join the two sets of conditions is to use an AND condition, and for that the operator you use is this ampersand. So for instance, if the condition you wanted was age less than equal to 10 and male equal to 1, then you would put this ampersand here. So in your case, sorry, here, you would use this type of a combination, because if you're using an ampersand to join two conditions, you would put if age less than equal to 10 and male equal to 1. In your case, you would do it with if adults equal to 1 and kids equal to 3, and then you put that ampersand in between. So let's try that command. I'm going to copy yours and put it over here. This is what Zach just suggested, and all I'm saying is to combine these two, you put an ampersand in here. And now it gives you exactly the same information as before, 5095.083, which comes up here. It provides additional information that this is coming from a combination of 6 observations. And for these households with 1 adult and 3 children, which were 6 observations, the standard deviation is 372.78, minimum is 4,600, maximum is 5,600, and the average is 5,095. So here the advantage was you got it for all households and children's combination. Here you got it just precisely for the group that you were looking at, but you also got slightly more information on it then. Generate a new variable for household size, which is equal to number of adults plus number of children. Find the mean expenditures for household with 4 members. Okay. Again, let's say that the new variable you want to create, let's call it size, because that's the number of people in a household. So for the variable called size, how would you generate such a variable? Write your comment or command in the chat. The variable you want to construct is called size, S-I-Z-E, and you want to generate it so that it is the sum of 2 variables, adults and kids. How would you issue this command? Please write it in the chat, whatever you think. Gen size equal to something. So gen size equal to kids plus adults. And that's it. If you now look at list in 1 in 10, first 10 observations, you see adults is 3, kids is 0, and size is 3. 2 and 2, 4. 2 and 0, 2. 2 and 3, 5, and so on. So it's created the variable that we wanted. So it says, okay, generate a new variable for household. Find the mean expenditure for households with 4 members. So now we do sum exp if size equal to 4. So the mean expenditure for households with size 4 is 118 observations are used to give you a mean value of 5302, and then it tells you the standard deviation min and max. You could use your tab command as before. So you could do tab size comma sum exp and list it that way. Then you have for all sorts of sizes of households their mean values. So for the size 4, it's the same information as was given before. Okay. Plot expenditure against household size. How precisely does expenditure vary with household size? Okay. So for that, we need to go back to our earlier sheet and look at the example from there, how to do plots. So a simple scatter plot that you can do between 2 variables is use the command scatter, first variable and the second variable. And if you do that, it provides this type of a scatter plot between them. Okay. So the 2 variables that we are interested in are, in our case, expenditure and size. So scatter exp size, and if we plot that, it shows this type of a scatter plot. What is it telling us? It says plot expenditure against size. How precisely does expenditure vary with the household? You can see it varies pretty straightforwardly. I mean, as size is increasing, as there are more people in the household, expenditure is going up, which kind of makes sense. Generate expenditure per household member as a new variable and investigate how this varies with household. Can you explain your findings using economic analysis? Okay, so how do we first generate expenditure per household member? What do we need to do to generate expenditure per household member? So again, we need to create a new variable, and here let's decide on a name. Let's call it EXP PC, so PC for per capita or per person. So I'll call it Gen EXP per PC, so per capita, equal to EXP divided by size, because that's the number of people. You follow that? Now we can do the same thing. It says investigate how this varies with household size. So previously we had scatter expenditure with size, that was this. Now we're going to change it to, instead of this variable, we're going to see how the new variable works with size. So here to be EXP PC with size. Aha! Now the shape changes quite a bit. It says that in households with very small number of or few people, there's a very large variance. There's a lot of scatter over here in what the expenditure is per person. But as the household size increases, the expenditure per person is decreasing. Why? Because you have more mouths to feed and fixed amount of income. So you're going to per person spend less money. So not only is there a downward trend, but also the variation decreases. Why? Because you don't have the luxury anymore to say how much to spend on expenditure versus how much to save up for holidays or for savings or whatever. Whatever money you have, it's going up for spending towards it. Okay? So that's how we go through all these questions and answer it one by one. Any questions about it? Are you guys still there? Okay. All right. So the solution to this exercise is also posted on the website, on Blackboard website, and I encourage you to do the exercise number 1 as well, which is based on the theory. And tomorrow we'll do some more exercises. Could you please repeat how to generate expenditure per household number? So I use the gen command. It's over here. Let me write it in bigger font in case it's not the. So I issued a gen command followed by the new name, whatever I want to call it, equal to formula. So the syntax is as follows. New name, new variable, gen, new var equal to formula that you want to use. So this is the syntax that I've used. And per this syntax, I should gen equal to expPC. This is the new variable I'm constructing. And then expenditure per member is total expenditure. And we had already created a variable called size, which was counting how many people were in a household. Is that clearer, Gianbo? Okay. Other questions, anyone else? All right, if there are no more questions, then we can log off. This is the total amount of material I wanted to cover today. And the recording is there, so hopefully if you need to go back and see any parts of it, you can log back on. But like I said, the solution for this particular exercise is also posted, so you can also look at the commands quickly on the solution manual that's there. Otherwise, I'll see you guys tomorrow. Thank you for joining in, and tomorrow will be our last session. All right, take care. Thank you. Bye-bye.